Now we have the second use case where you'll have to implement a route deviation. So this is the main purpose of vehicle route analysis, so that you can find out the route deviation, whether there are any route deviations or not. Now the question is, what is this route deviation? I might have already told you that what happens in organizations like petroleum organizations or logistic organizations or delivery organizations, meaning supply chain organizations, is that they prepare a route beforehand from, let's say, point A to point B. Now that route factors in a lot of considerations. So where the traffic is less, which route would consume lesser fuel, which route would be the shortest, etc., etc. So there are a lot of things which are considered, based on which the route is calculated beforehand. And the vehicles are directed to use the same route only. There might be a little bit of deviation here and there, but in most of the cases, the vehicles do not deviate from their predefined route. If there's a deviation by any vehicle, then it would be flagged and the information would be sent to the vehicle multiple times after a certain frequency. And if the vehicle pilot does not respond, then certain actions are taken. So that is what the route deviation information is. Again, the main purpose is to find out whether the vehicle is following the predefined route or not. So the real-time route coordinates, which is the route latitude and the route longitude or the route lat long, are sent to the vehicle pilot or driver using an app. So the display of the vehicle would have the route information just like a Google map, let's say predefined Google map, and the route would be sent or would be displayed in the vehicle's monitor. And each vehicle should follow the route which is sent to the vehicle pilots or vehicle drivers. Now, how do you find out whether the vehicle is actually following the route or not? I already told you at the beginning that the vehicle would contain a GPS tracker which would have Kafka SDK. So they would send their coordinate or their lat long to the Kafka topic. And then the application would find out whether there are allowable or non-allowable deviation or not. So that's why there would be two topics. One would be the vehicle topic, which would contain vehicle ID, vehicle lat long, and vehicle timestamp. Timestamp is when the event or the data point was generated, which is essentially the event timestamp. Then there would be route topic also, which would contain vehicle ID, route lat long, and route timestamp. So this is another event timestamp for route. The key should be vehicle ID, and the route would be sent from the headquarters of the organization, and the vehicle data would be sent from individual vehicles. Obviously there can be a lot of vehicles, and then at the headquarters obviously there will be some application running which will find the deviation of vehicles from the route data. And if the deviation is more than a certain kilometers, then the information should be flagged, and then maybe the vehicle pilot or the vehicle driver would be contacted over phone. Now in this case, I'm saying that if the deviation is more than 30 kilometers, it is actually way high. It should not be 30 kilometers, but I have generated the data in such a way that 30 kilometers is actually normal. So we can ignore the 30 kilometers, or you can ignore the practicality of the number but implement the use case. But if you want to do the calculation based on more real life data, instead of considering 100 kilometer for 1 degree latitude, you can consider it as 10 kilometer. And same would be for longitude also. You can consider 10 kilometer for 1 degree longitude. In that case, if the deviation becomes more than 3 kilometer, then you flag the vehicle information in the console. But I would recommend that you do not change anything, because you might have already implemented the Havertzine formula in a different module and you'll have to use that here. So how do you calculate the deviation? First, you have to find out the lat long deviation, meaning the difference between the route lat long and the vehicle lat long, which would give you the difference in degrees. Once you get the difference in degrees, you'll have to find out the distance deviation, and here you'll have to use the Havertzine formula again to find the distance in kilometer. So if you have already implemented the Havertzine formula using Python function in the previous use case, use the same, or I would recommend that you create a module in Python to implement the Havertzine formula. And then if the distance deviation is more than 30 kilometers, then you flag that in the console. On only then you flag in the console. So what is the deviation and which vehicle is performing the deviation? So in that case, once you get the notification or once the organization gets the notification, they can contact the vehicle pilot or the vehicle driver saying that your deviation is way more than the allowed deviation. So please come back to your original route or follow the original route. So that's what route deviation is. And here you see that you have to implement only one use case. The reason is that the implementation of these three use cases or three business statements that I have given you are pretty complicated because of the involvement of Haversine formula. And that's why I did not want to add too many business statements. Please implement these, which will give you a fair amount of Python hands-on along with PySpark hands-on. And this is how the route deviation implementation should be. We have same file. Let's say for vehicle number 1, we have only one file. And you'll have to create two producers which will read from the same file and then send to multiple topics. Or you can create a single producer also if you want. So one would be the vehicle location topic and the other one would be the route topic. And then you'll have to use PySpark streaming application and display the output or the deviation output in the console. So you'll have to send the vehicle location to Kafka topic and route data to route topic. And you'll have to use again Python multi-threading to read multiple files using the same code. And I'll have to read from one input file and send data to two different topics, which is something that we have done in the hands-ons also. So these are the use cases or problem statements that I wanted to provide in a vehicle route analysis project. Please go ahead and implement this. And if you face any problem, obviously you can discuss about this in our cohort meetings on the weekends. So all the best. And please go ahead and implement this because, as I said, the Python implementation would also be complex. So would be the PySpark implementation. But if you do this, of course, you'll get fair amount of exposure to PySpark and Python both. Thank you so much.